In this video, I'm going to find the gradient of these scalar fields at the given points. So I'll start by looking at the first one there. So what I'll do is I'll enter the code. So I'll go to my live editor there, and then for the code. The first step is to create my symbolic variables, x and y. Just suppose you are having x and y. This is a function of x and y here. Then I will now go on and enter the function. I'll call it f1. So my f1 is equals to the exponent, open parenthesis, x, then multiplied by sine of open parenthesis y. So that's my f1 there. Then after entering my f1, I then go on and find the gradient of this scalar field using the function gradient. So it's a gradient. Then open parenthesis, we are saying the gradient of the f1 that I have just entered there. So this function here will give us the gradient of the scalar field with respect to a default vector constructed from the symbolic variables in f, of which in this case, the symbolic variables in the f that we've entered, they are just x and y. So it will give us the gradient there with respect to x and y. So I can go on and run. So we have the gradient there is this vector, which has two elements, exponent of x sine y and exponent of x or sine y. But in this case, our question is asking us to evaluate the gradient at the point 0 pi. If we want the gradient at the point 0 pi, what we would have to do now, I'll just go on and edit here so that I enter my v. My v is equals to x, y. So that's our v. But for our gradient here, I will then go on and edit and call it G1 is equals to this gradient here. This gradient here, we are evaluating it with respect to v. So that's the gradient with respect to v. I can just run there. So it gives us the G1 is equals to exponent of x sine y and exponent of x cosine y. That vector there with two elements. So to evaluate the gradient at the point 0 pi, I will use the function subs. So it's subs, then open parenthesis. We are looking at the G1, the gradient we have just evaluated, then comma. So we are looking at for the gradient where we have the vector v there, comma. We are replacing with the values 0 pi. So it will be 0, 0, then comma pi. 0, pi. So that's the command that we use there. Then we can just go on and run here. And we have the gradient there at the point 0 pi gives us the vector which has elements 0, -1. So this is the gradient at the point 0 pi. I now move on to the next question here. We are now looking at f of x, y, z is equals to ln of x squared plus y squared plus z squared at the point 1, 2, 3. In this case, we are now having variables x, y, z. So in our symbolic variables, I'll just add another variable there, z. So I'll enter that one and I'll call it my f2. So f2 is equals to, for the natural logarithm, the command that we use is log. Log, then open parenthesis, we are saying x squared, then plus y squared, then plus z squared. So that's my f2 there. And you want the gradient there with respect to v to the x, y, z. So I'll call my v2 is equals to x, y, z. So I've defined my v2 there. Then I'll go on and now evaluate the gradient. So I'll call that gradient g2 is equals to gradient, open parenthesis, we are saying the gradient of f2 with respect to the v2. So I can just run that there. And it gives us the gradient there of this scalar field is this vector, which has elements 2x divided by x squared plus y squared plus z squared, 2y divided by x squared plus y squared plus z squared, 2z divided by x squared plus y squared plus z squared. So that's the gradient of this scalar field. I can now go on and evaluate the gradient of this scalar field at the point 1, 2, 3. So I press the return key here, and I'm going to use the function subs like what I did here. So it will be subs, then open parenthesis. Then we are saying where we have G2, we are replacing the V2 with, then open braces with 1, 2, 3. So in the gradient here that we have, we are replacing the x, y, z, because we are saying the V2 is the x, y, z. So we are replacing those x, y, z with the values x equals to 1, y equals to 2, z equals to 3. So I can then go on and run, and it gives us that the gradient of this scalar field at the point 1, 2, 3 is the vector which has elements 1 over 7, 2 over 7, 3 over 7. So that's the gradient of the given function at the point 1, 2, 3.